This presentation will be exploring a rich task that invites students to build a better world by considering wheelchair accessibility in their environment and building a ramp prototype to address the inaccessible areas. This rich task is appropriate for grade 9 students. It builds on concepts from grades 7 and 8. The engineering design process, or EDP, is a project-based tool for problem solving. The process is a series of iterative steps that allows people to address problems with a solution-oriented focus. There are no limits to what the EDP can accomplish, as it allows for steps to be repeated as many times as required. Solutions are imagined, tested, and then realized through the process of uncovering new design possibilities. The lessons learned from failure are essential to the progress, as it allows space for ideas to be explored. Project-based learning engages learners of all ages and fosters STEM literacy. Ask. Identify the needs and constraints. The ask portion is the initial step of the engineering design process. It is where the students identify the needs and constraints of the proposed problem and ask critical questions about what is to be created. These questions are framed around addressing the big picture. Examples of these questions include, what is the problem to solve? What do we want to design? Who is it for? What do we want to accomplish? What are the project requirements and limitations? What is our goal? For this assignment, students will identify the needs and constraints of wheelchair ramps. The main objective is to understand the parameters of what makes a properly designed, portable wheelchair ramp and design a prototype that could be used in location to make it wheelchair accessible. This location could be either in the student's home or around school. The research step is foundational to the engineering design process.
So the purpose of this assignment is to determine whether your home or an area around your school is wheelchair accessible or not. So for this engineering design process, our group is determined to build a prototype for this front entrance in my home. So right now it's not wheelchair accessible, but we have 2 steps about 1 foot high, and we're determining what the optimal ramp would be to make this home wheelchair accessible. So we're going to be building a prototype, not building the actual thing, because that would be quite big and expensive. But for this assignment, we're determining just the prototype. We're building it, designing it, and making it optimal. So it's going to be great.
In the research step, this foundational step involves attaining a comprehensive understanding of what products or solutions already exist in addressing the proposed problem. Engineers could conduct their research by searching online resources or talking with various specialists in their field. For the purpose of this assignment, online resources will be sufficient. The students will research what goes into constructing a safe wheelchair ramp by focusing on standards, designs, and materials needed to do so. The attached photo here is a photo of a group member's front entranceway that will be used in an example making this home wheelchair accessible. Imagine. The imagine portion of the engineering design process is where students will brainstorm possible solutions to the problem. This is where the teamwork is required in order to imagine as many solutions as possible. The students can build on each other's ideas and are encouraged to be as creative as they want. Once the students have come up with a number of viable solutions, they move on to the next step of the process. The images here describe the parameters of the proposed prototype. The front entrance steps are 1 foot high. Based on the research conducted, a portable wheelchair ramp is required to have a slope of 2 to 12. That is, for every 2 units high, the rise, 12 units must be extended to the side, the run. Therefore, a 1-foot rise requires a 6-foot run to meet the required slope. Plan. The plan step is very important as it requires narrowing down the list of ideas to the best viable option. It can be difficult for students to pick which idea is best. However, the engineering design process makes room for failure and encourages revisions to the design along the way. Therefore, students should discuss the pros and cons of their designs and present the final solution. For this example, the picture details the selected prototype. The prototype dimensions are scaled down to 1/112. So 1/12 of the actual size. Instead of a 12-inch rise and a 72-inch run, the prototype will be 1/12 the size, exhibiting a 1-inch rise and a 6-inch run. Also, the minimum required weight for a ramp should be at least 300 pounds. Scaled down to 1/12, our prototype should be able to support 25 pounds as the minimum required weight. Therefore, the prototype needs to be constructed well enough to hold 25 pounds. This is crucial as this part will be assessed by the teacher. The create step is where all the research and design comes together. This is the fun part. Students will need to identify the materials needed to construct their prototype and have a drawing that will follow. Students should stick with the design as close as possible. However, in the process of building the prototype, students may notice errors in the designs and make possible improvements along the way. If this is the case, they should consult with the group and proceed accordingly. Now let's build the prototype. The test and evaluate step is really where the rubber meets the road. This make it or break it stage is where all the research, brainstorming, design, and construction came together to create a working prototype. For this assignment, students will need to test their prototype to determine if it can support the minimum required weight of a wheelchair ramp. The 1/12 scaled down weight for the prototype is 25 pounds. The students will place the ramp between two books and gradually apply weight until it can carry the minimum required weight. After that test is complete, students will place their ramp at a slope and perform the same test. As you can see, the ramp is at a slope of 2 to 12. Improve. The improve step is essential for the engineering design process as it allows for further development and refining of the prototype. If the prototype succeeded, questions could be asked about how to make the prototype more efficient. Could it use fewer materials? Could it be made more cost-effective? What other materials could be used? If the prototype failed, student could ask why it failed, where did it fail, and how could the design process be improved in order to succeed in future tests. Students can iterate their designs in order to make them better. It's a repeatable process. This video is the second design. Students are encouraged to try multiple different things and see what works best. Connections to STEM. This project, this rich learning task, is connected to all the different elements of STEM. Science, understanding dynamics of loads and forces on objects. Hypothesizing, testing, observing, analyzing, and coming to conclusions. Technology, using tools to design a blueprint and build the prototypes. Utilizing online resources for ideas. Engineering, using the engineering design process in order to build a wheelchair ramp prototype. Designing and innovating. Math, geometry implemented in real life, involves an understanding of angles, slopes, and scales. For the first mathematical concept in this project, students will need to utilize their knowledge of geometry, specifically the slope that a particular right-angled triangle generates, as this will be essential in designing the wheelchair ramp that is a right triangle. By understanding the sides of the triangle, students can determine the rise and the run to eventually determine the slope of their ramp. Students need to select an area of their school or home that they think is inaccessible for a student or visitor requiring wheelchair access. The vertical side of this slope would be the rise. The horizontal side would be the run. To determine the slope of the triangle, which has the formula of rise over run, take the height of the vertical side and divide it by the length of the horizontal side. According to the Canadian National Building Code, permanent wheelchair ramps require a slope of 1 to 12. That is, they must have a rise of 1 inch for every 12 inches of run. This allows wheelchairs to climb the ramp in an easy and safe manner. If the student selects a space in their home where they need a portable ramp, they may want to consider a 2 to 12 ratio because it's more considerate of small spaces. This is the ratio that our prototype will model. The stairs that the prototype is being designed for have a rise of 1 foot or 12 inches. Therefore, the run must be a minimum of 6 feet or 72 inches in length in accordance with the 2 to 12 slope requirement. This will cause the slope to equal 1 over 6 or 0.1667. 0.1667 equals 1/6. For this task, wheelchair ramp safety is of the core concept. Groups will draw different triangles with different slope ratios, determining which slope is steeper. Working groups will take turns to understand and observe the entrance of the building, and based on their work, they can clearly understand why a slope is important in designing the wheelchair ramp prototype. Considerations will need to be made by the students in order to determine how large and steep the ramp will be in each location. This will help them understand the 1:12 and/or the 2:12 ratio that will be appropriate for most public buildings. Once they decide which ratio will be more appropriate for their space, students can measure the rise and the run, the slope, at each entrance and use that to determine the hypotenuse of the triangle for their written component. Students will then build the prototype based on the most suitable dimensions by multiplying or dividing the ratio by whatever scale factor is appropriate. This combines both mathematical concepts. The objective of this mathematical concept is for students to visualize the areas they interact with on a daily basis and see how they can make it accessible. The concept will also teach students empathy in a way that uses STEM concepts to empower students to apply their learning to benefit society. This concept aligns with the Alberta Education Program of Study in the Shape and Space Measurement section, where the objectives for 8th grade students are to describe the characteristics of 3D objects and 2D shapes and analyze the relationships among them. While the required outcomes that follow this is to draw and construct components for 3D objects. This knowledge will benefit students in constructing their ramp prototype. Possible misconceptions. If the concept of slope is not understood clearly, students may confuse the x and the y axis of their triangle. By viewing these as rise and run, followed by modeling this base and height in their own prototypes and the eventual build, students will probably see the correlation between rise and run and the x and y axis. Math concept number 2, division. Students will apply their knowledge of division to create smaller prototypes and create a prototype of a portable wheelchair ramp that maintains a 2:12 slope ratio. Students will determine the optimal size of their prototype by scaling the real-world ramp down to a functional prototype size. This will be done by the math concept of division. Division in this activity can be understood as how many times larger or smaller one number is than the other. If we want to make a ratio 12 times smaller, we will divide both of the numbers by the factor of 12. The actual size of the real-world ramp would maintain a 1 foot, 12-inch rise and a 6 foot, 72-inch run. These dimensions are too large to build and test the prototype. Therefore, our EDP process led us to design a prototype that has a rise of 1 inch and a run of 6 inches. This size for a prototype is a lot more manageable. This was achieved by dividing the actual measurements by a scale of 12. Our prototype ended up being 1/12 of the size of an actual working wheelchair ramp. To calculate the minimum required weight that the portable wheelchair ramp is required to support, we also had to divide the real-world amount of weight, which is 300 pounds, by a factor of 12. This calculation led us to determine that the minimum required weight of the prototype that we had to support would be 25 pounds. Dividing by a scale factor of 12 means that the ratio, 12 inches over 72 inches, can be reduced into equal, smaller form that could be fit into it 12 times. Both of the numbers, 12 and 72, can be broken into groups of 12 equally, which is why 12 is the factor. Therefore, the prototype ramp is 12 times smaller than a real-life scale wheelchair ramp. This division process will also be used to scale down the weight from 300 pounds to 25 pounds. That's a factor of 12 as well. This concept meets the requirement of Alberta Education's program of study due to the developing number sense. Students will build on their previously learned knowledge of division and apply it towards solving problems that involve rates, ratios, and proportional reasoning. For more complex calculations of constructing the ramp prototype, students will demonstrate an understanding of multiplying and dividing positive fractions and mixed numbers concretely and symbolically. The specific outcomes of the program of study will be met when the students decide what specifications are required for scaling down their real-life ramp. Possible misconceptions. Students might imagine that all numbers involved, even the slope, are made smaller by the division. This is also true of the x and y axis, or the rise and the run, but not the slope. By dividing both numbers in a ratio scale factor, the numbers themselves are smaller, but the ratio remains equal. Science concept, gravity and weight. Besides the steepness of the incline, another key safety feature of the ramp would be the maximum weight it can hold. Weight is the amount of gravity pulling downwards on an object. Students will place weight on their prototype ramp to ensure that it can meet the weight requirements. Portable wheelchair ramps are rated to support between 300 and 800 pounds. For a ramp that's scaled down to 1/12 of the size, the ramp should support 25 pounds minimum or 66 pounds maximum for the required weight. One effective method of students accessing the effectiveness of their ramp prototype would be to place weights on the ramp. If the ramp can withhold the weight, students have met their goal. By calculating the weight and therefore the amount of gravity pulling downward on the ramp, students will be able to see how much weight their ramp can hold and ultimately determine if it would be safe enough. Alberta Education's program of study looks at structures and forces, which states that the learning about structures, students can investigate the properties of the materials used and test them under different loads and forces. They examine different weights that structural components are configured by and analyze the forces involved to investigate the resulting effects on the structural strength and stability. The scientific aspect of this task corresponds with Foundation 1 of Alberta Education's program of study as it's related to science, technology, and society. The assigned task requires students to look at the relationship between science and social and environmental aspects. Possible misconceptions. Students may have the misconception that gravity only acts on falling objects, like a bouncing ball. However, by placing a weight on the prototype ramp on non-moving objects, students can see the gravity acting on the ramp as the prototype bends from the weight. Assessment. During assessment, we'll be looking for students actively engaging in the engineering design process. That includes how they worked with experimentation, assessed their own work, and made revisions in response to their self-assessments. The engineering design process emphasizes an evolving work progression. So instead of our assessment being solely based on their final product, a majority will be focused on to what extent they made revisions to their original plan based on their own self-assessments. The functionality of their product based on their plans. The ramp should be able to support the minimum recommended weight of 25 pounds. Did the students make revision in ways that improved upon their initial plans and made for a more functional ramp? Improvements for future research. The final product may not have come out as the students expected, but a reflection of how they might alter their plans in the future demonstrates their ability to fully engage with the engineering design process and shows evidence of innovative thinking. Overall, teachers should use the assessment for learning model as an assessment strategy that will focus on assessment throughout the entire process. Teachers can observe the areas of the engineering design process where some students have strengths and where other students might need improvements in the same areas of the project. Assessment as learning. Allow students to assess their own work as they work independently on complex STEM projects and how they approach problem solving in different steps of the project. This gives students the confidence to reassess at different stages in their own design process. Thank you for considering using this rich task to help your students learn STEM concepts while building social conscientiousness and building a better world.